Hi everyone, welcome to Focal Academy. In this problem, here how to find maximum average power for a load impedance. So here load was given as impedance. Impedance means having real part and imaginary part. Now how can you find ZL which draw maximum average power from the given circuit? How can you find it? So here we need two calculations. One is Thevenin's voltage and Thevenin's resistance. But here the circuit having reactive components, that is inductor, capacitor is there. So we will get first step is Thevenin's impedance. So from that we will get load impedance and Thevenin's resistance. Now first of all I am going to find VTH. How to find VTH for the given circuit? So when you are going to find VTH, remove this load. Simply remove this load. After removing this load, the circuit will be redrawn as like this. So I remove the load like this. So here whatever the voltage is there, that is called as VTH. Now observe carefully here the circuit. So this branch is open. So there is no voltage in this branch. So whatever the voltage across this branch, that is called as VTH. Now how can you find the voltage across this branch? So let's consider having this is impedance Z1 and here there is the impedance Z2. So here Z1, Z2 are in series with this voltage. This is open, no use. So now we are going to find voltage across this branch. So according to voltage divider rule, we know that whenever two impedances, that is Z1 and Z2 in series with a voltage, so then how can you find the voltage across Z2 according to voltage divider rule? So voltage across Z2 can be written as, so wherever we want voltage, write that impedance, that is Z2 by overall impedance, that is Z1 plus Z2 into source voltage. It gives the voltage drop across Z2. Now you are going to find voltage drop across Z2. Here Z1 is 4 ohms and Z2 this branch, that is 8 plus minus J6. Now according to this you can find the voltage drop across this branch. Take Z2 value, that is take this impedance, that is 8 minus J6 by total impedance, that is Z1 plus Z2. So 4 plus 8, 12, 12 minus J6 into total voltage supply, that is 10. It gives voltage drop across this branch. So it is nothing but VTH. So this is the process of finding the VTH. Now use calculator because it was in the complex numbers form. So convert into the phasor form. It becomes 7.454 with phase angle 10 minus 3 degrees volts. So this is the VTH. In the next step, we need to find RTH, but directly we can't find RTH. Why? Means the circuit contains reactive components, that is the capacitor and inductor is there. So for this, we will get some complex value for the overall impedance. So from that we will get load impedance and RTH. Let's see here how to find. So first of all we find ZTH. So for that, short circuit the source voltages. Means if there is a voltage source is there, make it as short circuit. If there is current is there, make it as open circuit, and Z will be removed. So from this we will get ZTH. If there is no reactive components, we will get directly RTH. But here reactive components is there, that's why we will get ZTH. So from this we get ZL and RTH. So here only one voltage source is there. So whenever voltage is there, make it as short circuit. Then circuit will become like this. Like this. Because here this circuit is used for finding VTH. Now in the circuits, make the source voltages as short circuit. So from this we get ZTH. ZTH means overall impedance. So here 4 ohms is means this branch is parallel with this branch and again series with this branch. That is 4 is parallel with impedance of this branch. That is impedance of this branch is 8 minus j6. Add these two values because whenever impedance is series, the overall impedance is equal to sum of their impedances. That is 8 minus j6. This will be again in series with j5 plus j5. It gives ZTH. Now here applying the parallel formula becomes 4 into 8 minus j6 upon 4 plus 8 minus j6 plus j5. That's equal to ZTH. So by using calculator, by simplifying this we get 2.933 plus j.467 ohms. This is ZTH. Now from this we can get load impedance and Thevenin resistance, that is RTH. So here observe carefully here. Here load is impedance given. So whenever load is impedance given, so what is the relation between load impedance and ZTH? That is ZL is equal to ZTH conjugate. Suppose here load in the place of load, pure resistance is there, RL. It becomes magnitude of ZTH. This is the process. But here load is complex, means impedance is there. Use this formula. It becomes ZL equal to conjugate means minus R apply. It becomes 2.933 minus J4.467. This is ZL. So this much impedance is needed to withdraw maximum average power. Now in that, this is the real part and this is my part. So real part is called as RTH. So RTH is equal to real part of load impedance, that is 2.933 ohms. In the next step is how to find maximum average power. In some problems, there you find maximum power only, there is no average. So the two are different. So let's see here. So one problem will be maximum average power, another is maximum power. So whenever maximum power is given, so then what is the formula? It is P max equal to magnitude of VTH square by 4 RTH. This is the maximum power formula. So in that, make it off, you will get maximum average power, that is maximum power, that is P max, thus equal to magnitude of VTH square upon 8 RTH. So here we have a problem on maximum average power. Now apply this formula. Now I am going to apply this formula here. So here we need VTH value. So VTH is already calculated. So that is we got 7.434. This is the magnitude. Now apply this value here. We will get 7.454 whole square upon 8 into RTH we got 2.933. So by simplifying this we get 2.368 watts. So this is the maximum average power. So finally we got load impedance. Load impedance is conjugate of Thevenin's impedance, and from that we'll get real part, that is called Thevenin's resistance. Now substitute the value here. VTH we already got. Now this is a process of simplification for getting load impedance and maximum average power. And thanks for watching. Please subscribe, like, share. Thanks.